Okay, this is section 8.4 on solving algebraic equations with variables on both sides. These are 5 questions from pages 327 in section 8.4. We're going to start with question 8. And question 8a says 2.6 plus 2.1k, or 2 1/10 of the value of k, is equal to 1.5 plus 4.3k. So this is a fairly easy question, and I guess the question you would have seen maybe in grade 8 would have been 3 plus 2k is equal to, let's say, 2 plus 4k. Okay, in this case, if I was to draw it out, I'd have 3 on this side, I'd have 2k on this side, I'd have 2 on this side, I'd have 4k on this side. And the idea in this red grade 8 version of the question is to maintain balance or to maintain equality. If I was to take away 2x from this side, whatever the value of x is, taking away 2 of those values from one side and taking away 2 of those values from the other side would maintain equality. And in this case, if I did that, I'd have 3, I'll just write down 3, is equal to 2 plus 2x left if I subtracted 2k from both sides. And again, what that would look like, it would be minus 2k here and minus 2k on the other side, 0 pair, 3 is left, and 2 plus 2k, not x, would be left on that side. When we bring this up to a grade 9 question, the only difference is we have decimal constants and decimal coefficients, but the same idea holds true for this one. So in this case, we're going to subtract 2.1k from both sides. I'm going to be left with 2.6 equals 1.5. Now, when you are combining polynomials that have decimal coefficients, since they are like terms, I can add and subtract them. And if I want to think about what I'm really doing, I'm really combining just the coefficients. So in this case, it's like a chapter 2 question on rational numbers. What is positive 4.3 and a negative 2.1 combined? We have more positives. How many more do you have? You have 2.2 more of them. So therefore, when I combine those two terms, I end up with 2.2k. Now we have the variable on one side of the equation, which is our first step when we have it on 2 steps. Let's get it, or 2 sides. We get it on one side. Get rid of your constant next by subtracting 1.5 from both sides. Rational number, we have 2.6 positive, 1.5 negatives. That means I have 1.1 positives equals 2.2k. Divide both sides by your coefficient like we would do normally. 1.1 divided by 2.2, some of you could probably do that in your head. That's exactly half. So therefore, it's 0.5 equals k. Now, if you couldn't, you can grab your calculator, go 1.1 divided by 2.2, and it's still a half, right? And therefore, the answer is k equals 0.5. In the second question, B, you have 1/6 p minus 5 is equal to 1/2 p plus 2. Okay, now for me, I think we already talked about this before. I'll just look at this one. There's various ways we can write this one, and you should be familiar with all 3. You could write it as a decimal coefficient, you can write it as a fractional coefficient, or you could write it as half of p. Since all 3 of these things are the same thing, and the reason why this is because really we can think of it, a coefficient as a multiplier. So half multiplied by p, or p over 1. When you multiply your numerators, you get p. When you multiply your denominators, you get 2. So therefore, they are the same thing. And given that they are the same thing, generally speaking, when you write your first thing down, I always recommend just writing it that way. So instead of writing it this way, I'd have 1/6 of p minus 5 equals half of p plus 2. Okay? Now, there's various ways you could do it. You could subtract a half of p from both sides. That will work. Again, if you want to do it that way, you could subtract a half p. So you could subtract a half of p, subtract a half of p, keep your numerator, and subtract your denominator. The only problem is now I have a fraction that's less than a half, and I'm going to end up with a negative fraction, and I hate subtracting fractions when I end up with negative values. So rather than do that, anytime you have fractions, what I recommend you do is multiply that by the common multiple. In this case, your common multiple here of 6 and 2, if I write those down, what's the first multiple they share? The first multiple they would share is actually 6 itself. So in that case there, I'm going to multiply both sides by 6. Grab a different color. And since it's a binomial on that side, and a binomial on that side, I'm going to have to just expand it a little bit. So each of these terms here and here are going to be multiplied by 6. So 6 multiplied by p over 6. Again, if you're not using cross reduction, you have to start using it because that's going to end up being a p, or 6p over 6, which is still a p. And then 6 over 1 multiplied by negative 5 over 1 is going to be negative 30. You didn't really have to write this out, but since you're in the idea of fractions, you might as well keep it going. 6 over 1 multiplied by p over 2 is going to be 6p over 2, which is 3p, or if you cross reduce, it's going to be 3p. And 6 times 2, well, I won't do it again because you know what that is. The same thing as the last question, is 12. So by simply multiplying by a common multiple of the denominators in the fractions, you will end up with this equation. And now this is much more manageable. No fraction sense required. We're going to then subtract a p from both sides. And we're going to get negative 30 equals 2p plus 12. And again, the reason why I subtracted a p and rather 3p is because you could do it either way. It didn't matter what you did. But if you subtract a p from both sides, because you had more on this side, you get the positive coefficient, which is good. Subtract 12 from both sides. And 2p will equal negative 42. Simply divide both sides by your coefficient, and p will equal negative 21. Okay, negative 21. Press pause and copy that if you want to see it a little bit different. The third question, very time-consuming questions here, but anyway, 4.9 minus 6.1u equals negative 3.2u minus 3.8. This is identical to the question A. Very little difference between the two. I'm going to add 6.1u to both sides. Get rid of it here. I got 4.9 is equal to 2.9. Is that right? Now right here, if you're trying to figure out how to combine those two, just take your calculator and combine them. So I have a 3.2, a negative 3.2 coefficient. Add that to a positive 6.1 equals 2.9. So if you're having a difficult time adding coefficients when they're negatives and positives, especially when they're decimals, don't try and do the work in your head. Use a calculator and combine them or add them together, and you'll make less mistakes. Here you're going to add 3.8 to both sides because now you have just a constant. 2.9u is equal to 8.7. Divide both sides by 2.9. 8.7 divided by 2.9 is 3. U is 3. Solution. And the last question, D, I'm going to write it out as it is in the textbook, and then I'm going to write it out the way I would write it. 3/5 H. Okay, so this is what it looks like. The first thing I'm going to do is I'm going to think of this fraction as being 3h over 5 because 3/5 times h is what a coefficient does. Multiply the numerators, you get 3h. Multiply the denominators, you get 5. Equals, this is negative 7/5 h, just as an improper fraction, which means it's negative 7h over 5. So you got to think of mixed fractions as improper, and then do the same thing over here. So it would be negative 7/5 multiplied by h over 1, or h, would be negative 7h over 5 minus 1. So the only thing I really did is I rewrote it so I didn't have these god-awful fractional coefficients. In this equation now I only have two fractions, and the lovely thing about those two fractions is they both have the same denominator, which is really easy to determine what number I'm going to multiply both sides by, 5. Utilize distributive property, I'm going to get 20, plus, I can just cross multiply in my head and get 3h, but if you couldn't, 5 over 1 multiplied by 3h over 5, you either got 15h over 5, which is still 3h, or you cross multiply, you got 3h, equals negative 7h minus 5. And you can do the same work there because you're just going to multiply each part here by 5. Now I have a negative 7h on the right. I have a positive 3h, so I'm going to get rid of that negative 7h by adding 7h to both sides. I'm going to subtract 20 from both sides. And 10h is equal to negative 25, which means your h value will be negative 2.5. My fault. It is a fraction question, which means you cannot have a decimal answer, which means your answer should be x equals negative 2.5. Any questions so far? Okay. We'll move on to question 10. So question 10 is questions that have distributive property as well as variables on both sides. So it has two groups of q minus a tenth is equal to three groups of 3/10 minus the value of q. So here, the interesting thing is you could expand first and then work it out. Or you could, well, we're going to do that. We're going to expand first and work it out. So we're going to go multiply both sides by 2. So 2q minus 2/10 is equal to, expand, is equal to 0.9 minus 3q. This one has a positive 2q on the left and a negative 3q on the right. Get rid of the least amount of variable, which is negative 3q, by adding 3q to both sides. 5q, I wish it was 10q, then I could say you're welcome. 5q minus 2/10 equals 9/10. Add the constant of 2/10 to both sides to get rid of the negative constant. 5q, oh sorry, that's not supposed to be division, that's supposed to be adding, equals 1.1. Divide by 5 on both sides, and q will equal 2.2? No, 0.22, right? 0.22? I got to get my calculator, my brain's not working. $1.10 divided by 5 people should be 22 cents each, and it is, yeah. Q equals decimal 22. Questions? Concerns? Just stop me if, just blurt out my name or whatever, get my attention. The next question, B, is a half multiplied by x plus 1 equals a third multiplied by x minus 1. There is other ways to do it here. I could multiply both sides by 6 right now, but I found that it's easier just to keep people simple with one set of rules. Expand. So a half times x. A half times x is really going to be x over 2. And a half times 1 is really, well, anything times 1 is itself, so a half, equals a third times x, which is going to be x over 3. And a third times negative 1 is really itself, but negative is a third. So once we expand it, we get this, and then we're still going to multiply both sides by 6. Grab my green marker, red marker. We're going to get 3x plus 3 equals 2x minus 2. And we could have actually done that up top if we multiplied both sides by 6 to start. It would have worked, giving us, instead of a fractional multiplier to our x plus 1, we would add a 3 instead, and we would have ended up with that. Subtract 2x from both sides. X plus 3 equals negative 2. Subtract 3 from both sides, and x will equal negative 5. I'm going to skip question C because it's going to take us forever to do this video. We'll go on to D. 2x minus 1 over 2 equals 2x plus 1 over 3. So obviously, I'm dealing with an equation that just has two fractions with funky numerators. I'm going to realize that Mr. McDonald always said anytime you have fractions, multiply by a common multiple of the denominators, so 2 and 3 would have 6. And I'm going to multiply both sides by 6, so I'm going to rewrite it here. 6 over 1 multiplied 2x minus 1 over 3, sorry, over 2, When I cross-reduce, which you have to do here, you're going to get a 3 up here. And you're going to get a 1 down here. So the denominators are no longer a part of our expression. And it's simply 3 multiplied by 2x minus 1. So 3 multiplied by 2x minus 1 requires distributive property again. So that numerator is going to be this. When I multiply 2x minus 1 over 2 by 6, I get 6x minus 3, because this requires distributive property. And in the next one, I'm just simply going to go like this and say it's 2. And therefore, I'm really multiplying 2x plus 1 by 2, which would be 4x plus 2. If you don't believe me, I could have rewrote it, but I think you understand. Minus 4x from both sides. 2x minus 3 equals 2. Addez-vous ton 3 avec le cheese to both sides. And divide by 2, and x will equal. Is it a fraction we started with? I think so, right? It doesn't matter. 2.5 or 2.5. Okay, that's question 10. Any questions so far? None. Given that there are none, we shall continue on. I'm going to skip ahead to 13. This is a jar contains 76 more pennies than nickels. The total value of the pennies equals the total value of the nickels. How many nickels are there? So how many nickels are there? When you see that question, how many nickels are there? You know that when you first do a story problem like this, you're going to say x equals the number of nickels. Okay? You're going to say total value of the number of nickels. So, all right, this should be fun. So the value of the nickels equals the value of the pennies. So if I take the number of nickels, right, let's say there's 20 nickels, and multiply it by 0.05, which is the value of a nickel, that is going to give me the value of the nickels. The value of the nickels. And since that's the number of nickels there are, right? That's the number. There's 96 more pennies, right? So x is going to be the number of nickels, and there's 96 more pennies, so it's going to be x plus 96 as being over there. Oh, there's only 76 more pennies. Oh, well then that's not right. It should be 76 here. So here's what we got. So what we're going to do is I'm going to subtract an x from both sides. Or subtract 1x. So I'm going to have negative. This is not going to work out at all. What happened to my life? This is going to be embarrassing. This can't be right. What did I do wrong? Okay, all right, whatever. We worked it out. The equation was right. It was 0.05x equals 0.01x plus the value of 76 pennies, which is 0.76. When you subtracted your coefficient from both sides, you ended up with this equation divided. You got x equals 19. Now, 19 being the number of nickels means that 19 nickels would be worth 95 cents. And since there are 76 more pennies than there are nickels, there would be 95 pennies, because that's 76 more pennies and nickels. And when you add those together, both of them would equal 95 cents. Okay. Next question. All right. Without fear of being an idiot and not being able to do it, the question says, Atu has $28.50 and is saving $8.75 a week. Beth now has $104.75 and is spending $6.50 a week in her savings. How many weeks will they from now, will they all have the same money? So x will equal the number of weeks until they have the same amount of money. So we're going to have variables on both sides. So $28.50 is going to be the constant for Atu. And the constant on the other side is going to be spending $6.50 a week. So we're going to have, now has $104.50. Look at that again. Has $104.75. So that's their constant. Is saving $8.75 a week, which means a positive $8.75 multiplied by the number of weeks is saving that amount of money. And the other one is spending $6.50 a week for X number of weeks. So our two equations would look like this. Atu is over here. who is saving $8.75 a week. And the other one over here is Beth, who is spending $6.50 a week. So multiplying saving $8.75 a week multiplied by the number of weeks, and spending, which would be a negative value, looks like that. So the first thing we're going to do is get rid of it. So we're going to get rid of Beth's 650x on both sides by adding 6.5x. We're going to get 1415.25x plus 2850 over here is equal to 104.75. So now we have taken the amount of money Beth was spending, subtracted it from both sides. We create this equation. Subtract 28.5 from both sides. 15.25, that's a point, that's a 5. X equals, can't do that in my head, Monday morning, 104.75. Take away 2850 is 76.25. And then if I take that and divide both sides by 15.25, so divided by 15.25 equals 5. So when I divide both sides by 15.25, I get x equals 5. Now, oh my God, what does that mean? Fortunately for us, we've defined it already. X equals the number of weeks. So therefore, at this rate of Atu's saving $28.50 and having $28.50 and saving $8.75 a week, and Beth having $104.75 already and spending $6.50 a week, it will take them exactly 5 weeks before they have the same amount of money.